Hello students, today we will study the topic electric potential and potential difference. Let us consider a charge Q. This charge Q is having the electric field around it. So under this one region, this one area, this one space, this electric charge is going to exert the force on the other material. So this area, this region is called electric field. Electric field. Fine. Now let us suppose that in this one region, if I consider any point, let's say the point P in the electric field. And here, somewhere at infinity, we have the 1 coulomb of charge. We have 1 coulomb of charge. Somewhere at infinity, we don't know the exact place. Now, what I will do, I will just move this one unit of charge, 1 coulomb of charge from infinity to this point. Got it? What I will do, I will just move this one unit of charge from infinity to this one point. From infinity to the point P, I will move the charge. So here, what is the thing will happen that when I will move the charge from infinity to the point P, here the work is done. Work is done. Fine. Similarly, if I consider any other point, let's say the point, R. Okay. Now, in the same manner, from infinity to, if I move the 1 unit charge from infinity to the point R. So here also, what will happen? Work is done. Correct. So here, the word meaning electric potential is the work done. It is the work done in bringing the charge, to move the charge from infinity to the point. Fine. Once again, electric potential in the electric field. Okay. It is the work done to move the charge from infinity to that point. That is called as electric potential. Let us write the definition. Electric potential. So electric potential, it is the work done. It is the work done in bringing the unit charge from infinity to that point in an electric field. It is called as electric potential. Got it? Right. Now here we have the one more term, potential difference. Now let us suppose that this is the electric field. Now if I wanted to move the charge, the unit charge from point P to point R. So in this one case also the work is done. Fine. What I wanted to be move, that is the unit charge. I wanted to move from point P to point R. So in this one case also the work is done. So here in this one situation I have to be use the word that is potential difference. Okay. So here I am just moving the unit charge in the electric field. Earlier it was from infinity to the point P in the electric field, but here I'm moving the unit charge in the electric field from one point to the another point. That is called as potential difference. Fine. So potential difference. Potential difference. Potential difference. It is the work done. It is the work done. It is the work done. Where it is happening, the work done? Between 2 points. Between any 2 points. Any 2 points in an electric field. In an electric field. In an electric field, to move the charges from one point to the another point, or you can write in bringing the charges from one point to another. It is called as potential difference. Let I just remind you quickly that what is the difference between the electric potential and the potential difference. First thing we need to understand electric field. So electric field, it is the region around the charge or the charge body. That region is called as electric field. Fine. Now if I consider any point in the electric field, let's say the point P, and here we have the one unit charge from infinity. So here that unit charge I have to be moved from infinity to into that particular point, means here that is called as electric potential. Okay. Now potential difference is what? In the electric field, if you have considered any 2 points, not only the P and the R, if you have considered here P and here one more point, if you consider L, and if you are going to transfer the charges between any 2 points, in the electric field, right? In an electric field, that is the work done to move the charges from one point to the another point. That is called as potential difference. Got it? That is called as potential difference. And this one potential difference is going to be represented by the letter V. It's going to be represented by the letter V. Potential difference, I will write in short form. It's going to be represented by the letter V. Okay. Now according to the definition, how we can write the formula? So here, work done upon the charge. Fine. So potential difference is what? It is the work done. Okay. Potential difference is what? It is the work done. So what we are just moving, which kind of work is going on? That is to move the charges. So this will be the formula for the potential difference. symbolically potential difference, that is V is equal to work done denoted by the letter W, and this one charge is denoted by the letter that is Q. Therefore, V is equal to W divided by Q. It is the formula for the potential difference. It is the formula for the potential difference. Now if you have look it into the formula carefully, you can see the unit also. You can make the unit also according to the formula. We know that one how to make the formula, that is the unit according to the formula. Okay. V is equal to W divided by Q. It is the formula for the potential difference. What is the unit for the work done? It is joules. What is the unit for the charge? It is coulomb. Fine. So joules per coulomb. Joules per coulomb. It is the unit for the potential difference. Fine. It is the unit for the potential difference according to the formula. But we have the SI unit. SI unit for the potential difference is, that is, it is volt. It is volt, represented by the letter V, in the honor of the scientist Alessandro Volta. In the honor of the scientist called as Alessandro Volta, we will take the unit for the potential difference is volt. Fine. Okay. He was the inventor of the Voltaic cell, right? So for that sake, we will take the unit for the potential difference as, that is, volt. Now, how to define 1 volt? So when we will say the potential difference is 1 volt, when 1 joule of work is done to move the 1 coulomb of charge. Fine. So in an electric field, if we have moved the, if the work is done 1 joule to move the charges 1 coulomb of charge, then we will say the potential difference is 1 volt. So potential difference is said to be 1 volt when 1 joule of work is done, when 1 joule of work is done to move the charges, to move the 1 coulomb of charges, to move the 1 coulomb of charges. Fine. To move the 1 coulomb of charges, that is called as the 1 volt. Okay. Now this one, the potential difference, it is also called as voltage also. Potential difference is also called as voltage. It is also called as voltage. Fine. So as the potential difference, that is the, it is the work done. So can it be measured? Yes, the potential difference can be measured in the electric circuit by using the device called as voltmeter. Using the device called as voltmeter. So voltmeter, it is the device used to measure the potential difference between the any 2 point in an electric circuit, and it is always connected in parallel in the circuit. So let I show you how. Let us suppose that we have the electric bulb, and we have a cell and the plug key, and this is the ammeter. Okay, this is the direction of current. Fine. Now if I wanted to measure the potential difference between these 2 points across the bulb, so this voltmeter, it should be connected in parallel. So this will represent the parallel connection of voltmeter. And here this is the ammeter. It is connected in series in the circuit. So here voltmeter, it is a device. It is a device to measure the potential difference in an electric circuit. Which has high resistance. And always connected in parallel in the circuit. Okay, in the circuit. The word parallel and the high resistance. The voltmeter, it is having the high resistance and it is always connected in parallel, whereas the ammeter, it is always connected in series and which has the low resistance. So these two difference, you must know this one. And for the why this one, the voltmeter and the ammeter will connect always, that is the voltmeter in parallel and the thing that is the ammeter in series. For this purpose, I will make you the one more separate video for that one. Now presently, just to remember this one, the voltmeter, it is having the high resistance and it is connected in parallel. So this is the method to connect the parallel, the voltmeter. How to connect in the circuit means this is the representation to connect the voltmeter in the parallel. Okay. Now these are the things related to the electric potential and the potential difference. So remaining some of the numericals will be based on the potential difference that we will discuss in the next class. Thank you.